Hello, everyone. I'm Divya Rao. I work for a cybersecurity startup company called Endor Labs as a dependency management specialist. This is my first time to be attending this event in person. I'm really excited, and thanks, Kyle, for giving me the opportunity to present here. And today's presentation will focus on open source productivity and the risks that can come through open source software. A quick background about me. Before joining Endor Labs, I worked at Stanford and Indeed. I had various roles ranging from engineering to operations, and finally entered into cybersecurity world. All right. As a developer, if you move like 10, 20, 30 years back, we did not have the OSS support, or we did not have open source community support.
You're wandering around.
I'll just stand here then. So we would write code from scratch. And 20, 30 years forward, now because of the community support we have, believe it or not, 80% or more of any code in modern application is something that we do not write. And for GitHub, this number can bump up to 90%. I'm not sure about you all, but I was honestly surprised when I looked at these numbers. 47 million versions of different open source packages with over 3.1 trillion downloads.
I just want to attach to the necklace or the scarf, or not scarf, the shirt, sorry.
That's it.
Either hold it or.
Perfect. Thank you. Yeah. And guess what? It's not stopping there. It's growing year over year by 43%. So clearly, open source has exploded, right? And what's not to like, it's Wikipedia for developers, for us. Now, for us, open source was the best thing that could have ever happened. Like-minded people are coming together with a common mission, right? They want to give it back to the community. People, developers across the globe have come together. And these people are like-minded folks. They want to do something to the community. If there is any bugs or whatever, we get together, we get it resolved. So for us, it's of course feels like we are in Disneyland. If you consider example of Microsoft, they were not very open and upfront when it came to adopting open source. But now a company like Microsoft has embraced open source. So for me, of course, it feels like we are in Disneyland. But is that all it is? Absolutely not. I'm not sure if anyone in this room have experienced dependency hell, but for us, it's very, very frustrating when it comes to open source, especially managing all the dependencies. People in social media, consider LinkedIn or Twitter, they have specifically spoken about dependency hell. I'll give you one simple example. Updating one dependency can break all hell loose, because we don't know what's going to break, what's not going to break, what will be the impact at business level. And if you look at Jana right here, they even talk about having a role for managing all these dependencies. Now let's take a step back and talk about dependency 101. Now let's say we are building an application. We are looking for certain functionality that can do exactly what we're looking for. So we go to open source, we find a package that does exactly what we were looking for it to do, we bring them in. So as a developer, we are in complete control of what we bring in, the first level package, or that's called direct dependencies. We are in complete control, we are in charge of bringing that in. Anyone here, show your hands, can tell me how many indirect dependencies coming for a free ride for every single direct dependency on an average? Any guess? 50? That's close. Any other guess? That's close too.
The game show. Higher, higher.
Yeah, I would go a little bit higher.
73.
That is really close. Good job, kid. All right, the answer is 70 to 80. Every direct dependency brings about 70 to 80 indirect dependencies. Now, we have complete control here, a direct dependency, but this is where we do not have visibility, all the transitive dependency that comes in. And they represent a significant part of our application code base, and that can mount up to 80%. Now, another question to the audience here. What percentage of vulnerabilities can come through transitivity? Any guess? 10%, 80%.
30%.
Okay, that's a little bit on the lower side. Any other guess?
70.
That's close. A little bit higher. But the answer is 95% of the vulnerabilities comes through transitive dependency. And from the perspective of application, of course. Now at Endor Labs, we do program analysis technique that can determine reachability of vulnerability code, but program analysis, call graph, it's a complete different topic of discussion. Now that we know direct dependencies, we know transitive dependencies, we know how vulnerabilities can come through transitive dependencies, let's consider a bunch of examples. Before doing that, I have one more question for you all. How many of you here have visibility to unmaintained software? You can just show your hands. Okay, one.
What do you mean by unmaintained software?
We'll talk about that shortly.
How can we answer the question?
Okay. I think engineers will know what unmaintained software is, but let's take a look at it. Anyone familiar with Gorilla Toolkit example? So this is a classic example of a software that was unmaintained, and Gorilla Toolkit is now in archive mode and is no longer maintained. But if you look at the numbers, it had 10,000 weekly clone on each package, used over 90,000 repositories. And clearly it was a very popular software. You can look at the GitHub stars, it's 18,000. Now as a developer, when we try to bring a package in, we do a quick review, right? We look at GitHub stars and we bring them in. And if you look at this particular software, it has 18,000 GitHub stars. For me, it looks really good. I'll go and bring this package in. Now, let's say we come across a scenario where software goes unmaintained. We should have the ability to answer all these questions. Where are we using this dependency? What do we need to replace it with? Most importantly, what applications are affected? If it's affected, what part of my application code is affected? And finally, are we exposed to any risks, either security or operational risks? I really like this example. Have you seen the block diagram where there are a bunch of blocks and one block is handling all the other blocks? This example literally gives me the visual effect of that diagram. So Core.js was maintained by a single person based out of Russia. Now, this guy was in financial duress. He went to jail because he met with an accident or whatever reason that is. If you look at the software itself, it had 9 billion downloads, replied by top 1,000 websites and was used in 13 million repositories. Now, when this software went unmaintained, developers didn't know what was going on. They were sending email to this guy with no response back. After a point, that email started turning into a hate email. And this guy, when he came back from jail, he felt betrayed. Because like I was giving so much to the community, and what do I see? I see all this hatred email coming to me. Now we have to consider the risks that we are bringing into our org, right? It's unmaintained software. On top of that, it's the frustration of the single maintainer. Now, again, if we come across scenarios such as Code.js, we should have the ability to ask the questions. Are we exposed to any risks? What applications are affected? And what versions do we need to update it? This is an example of a attack vector, compromise of legitimate package. This framework by PyTorch was a very popular ML package maintained by Meta. Now, it was compromised. You can look between December 25th to December 30, and any users that downloaded this during that time frame were compromised. Again, I have the numbers here. You can look at the GitHub stars, 61,000. A framework that's maintained by Meta, who can understand, or who will think that it can get compromised, right? But it did. And used in over 187,000 repositories. If I were you, I should be able to answer questions, the immediate questions that, is my company exposed to any security risks, and what applications are affected? So we looked at a bunch of examples. Let's talk about OSS itself. I'm not here to scare you. Open source is great. We have to nurture, we have to foster this community. And I feel like we are doing a good job. We know the risks that's coming in through open source. But let's look at the three ones that I have here. Open source software is very complex, right? It's extremely complicated. It was meant to be a productivity boost for us, but in reality, it's turning the other way around. What do I mean by that? So all the vulnerabilities that's coming through are false positive. I would say 80% or more are false positives. And what's the impact on engineers such as ourselves? We do a complete code review of the vulnerabilities that's been pushed to us to go fix it, only to realize later that it did not affect our application code. So we spend 80% of our time just doing the entire code review, chasing behind false positive, where we should be working on shipping new software package, right? So we are wasting a lot of engineering productivity right there. The examples of unmaintained and outdated software that we just saw before, we need to have visibility to all the unmaintained and outdated software, because it can pose up massive operational risks and security risks as well. And finally, the next-gen software supply chain attacks are getting extremely sophisticated. Based on our research data, it's growing 650% year over year. That's massive. And most of the scanner cannot catch the sophisticated attacks. And we'll look shortly, we'll go in details of the different kind of attack vectors here. Now we know about all these OSS risks. How do we wrap our arms around this? Now this is very, very specific to Endor Labs. So we went back to the community. We spoke to dozens of CISOs, to be precise, 30 plus CISOs across the country, just to trying to understand what kind of risks really matters to them. And then we compiled a list of top 10 OSS risks that CISO would want it to get managed. There's a complete report that dives deep into every single OSS risks. I can share it towards the end on Slack channel. But OSS risks such as known vulnerabilities or compromise of legitimate package, unmaintained software, outdated software, all of these risks are extremely important, and we need to make sure we have visibility to all of this. Now let's take a look at the taxonomy of attacks. So my coworker, Henry, he was a researcher at SAP. He and his coworkers, they created a taxonomy of attack for all the open source of software supply chain attacks. Now, while proposing this paper, they had few things to consider. First was, should it be independent of specific programming languages or ecosystem? Also, they had to cover all aspects of software supply stages, including from code contribution to package distribution. And the full taxonomy itself takes a shape of an attack tree that covers more than 100 unique attack vectors. That's based on the study of almost 100 real-life incidents. Just a quick preview of the subtrees. Attack vector 1 talks about how these malicious actors develop and advertise distinct malicious package from scratch. Attack vector 2 is all about name confusion with legitimate package, and attack vector 3 is subverting legitimate package. All right, so here, I'm not sure if you guys are a fan of Star Wars, but I am. So here the attacker has created an OSS project with malicious code in it, with an intention for end user to consume it. Apart from just creating the OSS project, he has also targeted the end user, right? He has advertised it to the end user with an intention for them to use it. Here is the evoke guy. He's just here to get his job done. There's nothing suspicious at all. But there are real life examples. We can look at NPM, Docker Hub, or the Python package upload for your AWS keys. So these are all real world examples, not long back, but from past few years, we're seeing all kind of attacks that's been happening, and it's getting sophisticated as well. Attack vector 2, name confusion. So here, this consists of creating projects or artifacts that almost resembles to a legitimate package. Again, it has malicious code. Its intention is to target users with their end goal to consume by downstream users. So here, consider the example right here. He knows exactly what he wants. He's researching for a package that's written here. But if you look at the URL lib 3-1.221.1, there's just one character missing. And if you're in a hurry, you can completely miss that spelling mistakes, right? And just get that thing in. And that's how these attackers sneak in to your business. The example here is PyPy Python repository that was hit by typo squatting. Now, consider typo squatting as typographical error. Let's say you're searching for Django. So instead of DJNJO, it's DAJNGO. If you're in a hurry, you're completely going to miss that and just bring this in. Now, attack vector 3. This is the most dangerous one. It covers all attacks with the intention to corrupt the original legitimate package. So there are a few examples here where the hacker will inject malicious code directly into the source of a legitimate package. It can happen during the build of a legitimate package as well. And when they ingest malicious code during the build, it's very hard for the damage is already done, what I'm trying to say here, because during build time, it's very hard to catch them, especially for C languages. And they can also so here what they're trying is they're completely manipulating the original package with whatever end goal intention they have. Again, bunch of real world examples. Not long back, I think SolarWinds issue was a wake up call to us. And then Log4j happened 3 years back, and we're still talking about Log4j. So we know there is a real issue that's out there. We as a community, we have come together, we have identified the risks, and we are very careful now to protect ourselves against the OSS risks, against all these different attack vectors. Now that we looked at the attack vector 1, 2, and 3, which one do you think is the most prevalent of all? Attack vector 2. Yeah. Do you know why that's more prevalent?
One they have to develop. Number one, they have to develop.
Yes.
They're still developing.
Yep. Yep. It's relatively cheap to do it. It does not require a lot of investment. So, and that's how most of the attack happens. Based on this research paper, I believe 67% or more of the attack is through the attack vector 2. How do we protect ourselves? I think we're doing a good job here. Everything that you see here is where the industry have taken steps and precautions. They have SCA tools in place. They have software bill of material. We are doing manual audits. We are doing security assessment, vulnerability assessment. We are establishing the vetting process for open source. So we have identified safeguards. We are taking steps to make sure that we're protecting our business ourselves. We are moving towards code signing. We should also consider the low-hanging fruit, removing unused dependency or version pinning. I think that's where we need to focus more. And the block that you see on the center is the next-gen kind of attack, where I feel the industry is leaning towards more now. I think people here can resonate to this completely. As a developer, we are shipping new code, we are constantly innovating. We have to manage dependency health. We have to make sure that we are free of vulnerabilities, and the list just keeps on going on. To just protect ourselves from OSS risks itself has become like a complete job requirement. I wanted to, you know what? I have one quick thing that I wanted to share. So all the attack vectors that we talked about, if you go to Risk Explorer, it's just for your own knowledge. If you want to understand everything in detail and explore the attack tree, the attack vector 1, 2, and 3 we spoke about, right? But if you go in detail, if you click on this, you can understand and dive deeper and just go. If you want to learn more, you can even click on each of the individual attack vector to build that knowledge. But this is a really cool graph. I really like it. You can further deep dive. There are over 100 different attack vectors, but it's been categorized into 3 attack vectors. All right, going back to my presentation. I want to keep it for an open discussion now. How do you all manage your software use? Have you come across any kind of issues, complications, it's an open discussion for my understanding, for my knowledge. Hmm? Okay. So your company has already some guardrails and processes in place. That's good to know. All right, so that's it for me. Thank you so much for giving me this opportunity to present. Thanks, Kyle, again.
Thank you,
And I
Divya.
look forward to presenting more in future.
This was good. Does anybody have any questions here for Divya for about the software use or any of the codependencies or anything else that she talked about here? I mean, this is a hot topic issue with open source and other things like that to be able to try to figure out what you're actually using here and there. Let me see. I think somebody had said something online, but of course I can't get into it. I think the hardest part is what do you replace it with? Because that's what one of the people was mentioning online is one of the things you had was how do you figure out what you're actually replacing and then turn around and what's its dependencies and how it affects your code and other things like that. So that's actually what he viewed it, or he or she viewed it as their hardest.
Yeah. So going back to the dependency hell, I'm not here to pitch Endor Labs, but we are doing something different. I feel there are two problems when it comes to managing the dependency, right? Developers, we do not have the right telemetry, right metrics when it comes to selecting the right first level package. So we provide some score factors around security, quality, other factors that can provide developers more visibility on what first level package they can bring in. So that's one. And for managing the vulnerabilities through transitive dependencies, we can use call path. I'm not sure if you're familiar with call path, but we trace the exact path of, we basically create a map of the entire dependency tree, direct and transitive. And let's say if there is a vulnerability in your transitive code, we can exactly map it down and tell you if it affects your source code or not. So that way, the developers' productivity is restored. They're not going behind false positives. And when it comes to the business impact, you're focusing on the right alert. Did I answer that question?
I think so. Anybody else online want to come off and ask any questions?
Yeah, sure. One of the things that I think can help us with software reuse is if we have a internal repository that gets scanned and that we have a code reuse librarian or code checkout process that keeps accountability as to where we're using things, and automating that as much as possible using some of the tools that we have. What are your thoughts on that?
That's a great step to take.
How often do you see, I mean, do you all do this type of analysis in Endor Labs? How often do you see a organization having their own repositories that they clone stuff from, say, GitHub or GitLab, things like that, into theirs? Then they do the security assessment, make sure it's good before they release it to the developers. Do you see that often?
Yeah, so we integrate with most of the tools that's out there, GitHub, Bitbucket, GitLab, whatever they are. So we have a complete visibility of what the developers are bringing in.
Yeah, they do that internally through pipeline.
Sorry, what?
Let's get a serious question.
Yeah.
She was using an example, like saying organizations that do those things will have a package in GitHub that is pre-approved, and then people will check it. So she's not saying, correct me if I'm wrong.
Right. So
Companies that use GitHub to host stuff they have scanned, not a blanket of GitHub.
it could also be a private repository that they have either hosted at GitHub or they have their own Git service inside. Yeah.
Go ahead.
Sure. Yeah, so I'm looking at the risk explorer that you mentioned earlier, and the safeguards are aligned with, I think, to some extent, the attack vectors. And I just wanted to ask, how you guys align those attack vectors with other frameworks out there. For example, maybe the MITRE attack framework. Do your safeguards align with other control frameworks out there, like maybe the Cloud Security Alliance or OWASP or NIST CSF or the like?
That's a great question, but I think my coworker Henry would be the right person to answer that question. But you know what, I can go back to.
Let's see, Oscar, open software supply chain attack reference. That's another one. They want to know how it maps to that one. PBOM, interesting. I've never heard of that one. There's a PBOM.dev is another framework that somebody has out there. It's like the whole idea about standards. Just look around, you can find the standard that you want to follow, and there's so many. Oh yeah, let me pull the chat up here. So hold on. Yeah, open software supply attack reference, Oscar. Interesting.
No, I haven't.
So Endor Labs, so they haven't. She's not heard of this exactly, but like she said, sure, the mapping is really somebody else in the organization that can talk better to that. But this is very fascinating stuff. It's obviously very timely with all the dependencies we've all discovered. And if anybody has any other questions, Divya will be around in the room, I guess, for a while. And thank you all for. I mean, we can wrap this up unless everyone has any questions online.
Thank you.
All right. Well, thank you all very much. Thanks for attending us in July.
Thank you.
Thanks.